Okay, so today we'll be running through a methods year 11 practice exam. This is worth 40 marks. There may be a few questions which confuse you slash you haven't probably seen. Question 4 is probably going to be one of them, and part of question 2, which is the chain rule, which you can just skip over. So let's begin. Solve the following equations for x. 2 marks. So it's a decent amount of working, and we're actually told that x has to be bigger than 0. Sometimes with logs, you can have 1, 2, 3, but you can't have log 10 0, and you can't have log 10 negative anything. Log base of anything that is negative. But they've told us that whenever we have, for example, x equals 4 and x equals -2, we'll choose x equals 4. So let's get into it. First thing notice is this fine? There's nothing in front of it. Nothing in front of it is set to negative, but this is going to cause us some problems. So the way to fix that is bring it back here. So here's what we're going to do. We're going to go log 5x plus log 5 4 squared plus log 5 2 to the -1 equals 1. So what I've done is made sure there's a plus in front of all of them. You don't have to. If this isn't the way you would normally solve it, that's fine. There's many different ways for you to do so. So there's not one exact way. The basic principle is to combine all logs into the most simple form and go from there. Now, this can become x times 16 times 1/2 equals 1. So that means log 5 becomes 8x equals 1. Now we could go 5 to the 1 equals 8x, but realistically, whenever you see a log equaling 1, this is the rule. These two, the base and the thing inside the log, have to be equal. So 5 has to equal 8x, the x equals 5 over 8. And this checks out because x is bigger than 0 and 5 over 8 is bigger than 0. Cool. Now, key with this is to immediately spot a pattern. You should immediately go a is equal to 2 to the x, a squared is equal to 2 to the 2x, and turn this whole into a quadratic. Perfect. If this step confuses you, let me know, and I'll remake a video on how to further solve. This is now a factorizing part. I'll quickly do my method. There's multiple ways to do this, but first thing I notice is you have to do something times something equals -16, and something plus that same something equals -6. I've noticed it's a negative, meaning you have to have a positive number and a negative number, rather than a positive positive and negative negative, because if you multiply them together, it's going to be negative. Now, let's get all the factors of 16. 4 and 4, and it actually rotates. So 8, 2, 16, 1. But now we know that when you add them together, it's going to be negative. That means the negative number has to be largest. So these guys are out of the equation. And from here, if you add them together, this would become -15, -6, and 0. We got a winner. So it means we can split this into a plus 2 and a minus 8 is 0. This is a very simple method, but at first it can be quite confusing. So if this doesn't make sense at first, that's fine. You can do it your own method, but I would recommend moving on to this technique as it's very quick and very flawless. So we end up with a equals -2 and a equals 8. But we're not done there yet because we said a was equal to 2 to the x. So option 1, -2. 2 to the x equals -2. This is impossible. If you were to do a log, you could say log 2 -2 equals x. This cannot happen. This is undefined. And that's because there's a negative number inside this log. So then we go 2 to the x equals option 2, 8. We can do this slowly. X equals 3. So there's our answer, x equals 3. Noting that this is impossible is super important. Knowing that x equals log 2 -2 cannot work. Now, this is not to be confused if you had negative log 2, 2, or if you had log 2 to 2 to the minus 1. Indices can be negative, it's just the actual number that can't be negative. Okay, question 2. Find dy dx. Now, we don't actually have a formula to solve, so the best is to expand. 12x minus 4x squared plus 3 minus x. And I'm doing this times this times that, this times this, and that times that. And let's reshuffle this. So we have the squared at the front and the x's going in. And combine all like terms. There we go. Now that means dy dx is equal to negative 8x plus 11. Cool. Now, here we have the chain rule. So if you haven't heard anything called chain rule, just ignore it. So let's do this slowly. The 6. And let's let this equal y. Let u equal 3 minus 2x. This means y is equal to 5 times u to the 6. Now, dy dx is equal to dy du times du dx. So let's start with dy du, which is so for reference, y equals 5 u to the 6. The dy du equals 5 times 6 u to the 5. Now let's find du dx. So equals -2. So just take the derivative. So that means dy dx is equal to, which is also equal to g dash of x. These two things multiplied by each other. So we have -2 times 30 u to the 5, -60 u to the 5. And what is u to the 5? -60, 3 minus 2x to the 5 equals g dash of x. Perfect. Hence the value of g dash of 2. Okay. So we're going to have g dash of x equals -60 times 3 minus 2x to the 5. G dash of 2 is equal to -60, 3 minus 4 to the 5. There's -60, -1 to the 5, which is just -60 times -1 equals +60. Cool. Andrew simultaneously tosses 3 coins, one of which is biased. When a coin is tossed, the only 2 outcomes possible are a head or a tail. The probability of tossing a head on the biased coin is 0.4. Okay, lots of context. So there's 3 coins, 2 of them are even, 1 of them is biased. So in order to get a heads, it's going to be 0.4. This is probability. Now, the 2 normal ones, head for both. Head is 0.5 and tails is 0.5. Draw a tree diagram to represent this situation. So we're going to go first time. We'll call this one the first coin, the bias coin. The chance of hitting a heads is 0.4, tails 0.6. Now, we threw another one, heads, tails of the non-biased one, it's going to be 0.5. Again, somewhat self-explanatory. If it doesn't make sense to why this is not 0.4 anymore, just let me know and I can explain further. Now, the thing with methods is to always read the question. As silly as that sounds, let's reread it. Draw a tree diagram to represent the situation. Done. Ensure your labeled branches with probabilities and possible outcomes are listed. Cool. So we have not done that. So what are our potential outcomes? Heads, 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 tails, and then heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So we've labeled each branch tick, 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 tick. And the possible outcomes are listed. Now we haven't exactly listed the probability. Now let's check the mark. There's only one mark, so this should be okay for us. Find the probability that Andrew tosses exactly one head. Let's have a look at our samples to see exactly, is it one head? Exactly one head. There's one here, and that's it. Cool. Let's find the probability of this branch even happening. So you've got to hit the head first, 0.4, and then tails, tails. So this would be 0.25. 0.1. And then here it would be 0.6 times 0.5 times 0.5. We are going to end up with 0.15. So the probability is 0.1 plus 0.15, 0.25, or a quarter if they prefer that. Now, the way I got this is I got this from this probability, this from this probability, and this from this probability here. And same from here, here, oh, sorry, wrong one, here, and here, here. Oh, I actually missed one. This one, that's my mistake. So it would also be 0.6 times 0.5 times 0.5, 0.15. So scratch that. It would be, always check your work. Everyone is susceptible to a mistake. And yeah, and clearly I got these guys from going down this path as well. Let's go to the next question. Find the probability that Andrew tosses a head with the bias coin, given that he tosses exactly one head. So and he tosses a head with the bias coin. So given, this is going to be a given question. So it's a probability that he tosses a, we'll call it biased head, given that he tosses one head. This would be the probability of a body head intersection with one head over the probability of one head. So it would be 0.1 over 0.4, which is equal to 1/4. Now, that's because the probability of hitting the head was 0.1, and the probability of just hitting one head in general was 0.4. Okay. Consider the data in the probability distribution shown in the table below. And here's our table. Show that A equals 1 out of 12. Basically, with probability, the probability of anything happening is always 1. So if these are all the probabilities, we're going to have 2A plus 3A plus A plus A plus 3A plus 2A equals 1. Now, 5, 6, 7, 10, 12, A equals 1, meaning A equals 1 on 12. This is a principle of probability that probability of something happening, X happening, is this. Find the probability that X is smaller than 3. So that would mean here and here. So it would be 2 times 1/12 plus 3 times 1/12 equals 1 on 6 plus 1 on 4 equals 2 on 12 plus 3 on 12 equals 5 on 12. Find the probability that it's X is greater than 1 or in between 5. This would be here, 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 and including 5. Now, an easier way to do it is you would, instead of adding all those probabilities up, you do 1 minus the probability of X equaling 1 and the probability of X equaling 6. It's just the opposites. Minus 1 on 6 minus 1 on 6 equals 6 on 6 minus 2 on 6 equals 4 on 6 equals 2/3. Now I just quickly did 1 on 12 times 2, which is 1 on 6. Now, find the probability that X is less than 3, given that it's smaller than or equal to 5. What we're going to do is, what is the probability that it's actually less than 3? 5A, so 5 on 12. Over, and what's the probability of it being less than 5? 10 on 12. The answer is 1/2. Notice I did speed through these answers, because once you do tens and hundreds of these questions, they're very simple to see. But explaining what I did was, I found a probability that it's smaller than 3, 5 out of 12. And then I found the probability of it being 5 or less. And what I did was 1 minus just 6, because that's the same as saying all of this is the same as 1 minus just that. So 12 out of 12 minus 2 out of 12. And this fraction work you'll get used to. It becomes 5 over 12 divided by 10 over 12. Because 5 over 12 times 12 over 10. Crowns to cancel 1/2. Perfect. Question 5. Solve 2 cos 2x plus 1 for x is an element of 0 to pi. So we can't solve it in this form, but we can always solve something in this form. Let's put it into it. 2 cos 2x plus 1 equals 0. I'm going to go 2 cos 2x equals -1. Cos 2x equals -1/2. Now let's check what the period is. It was 2 pi on n, where cos n x. In this case, our n is 2. So that means our period is 2 pi on 2, which is pi, meaning one full cycle happens during this period. If a period was 0 to 2 pi, that means there's 2 cycles. So if we are only looking for one cycle, we know we're only going to get 2 results. So let's get our exact table up that we should be very comfortable using.
Now it should go 6, 4, 3, 2, starting with 0. Now let us write this out. Square root, on 2, on 2, on 2. Now, clearly we can see our reference angle is pi on 3. This is because we know that cos pi on 3 equals 1/2. And that means we want cos 2x to equal -1/2. So which quadrant must it be in? Second or third. We should be used to this. So it's in second plus third quadrant, meaning we're going to have 2x is equal to pi minus pi on 3 and pi plus pi on 3. Let's move it here. So 2x is equal to 2 pi on 3 and 4 pi on 3. And we're going to times that, divide that all by 2. So x equals pi on 3 and x equals 2 pi on 3. There is our answer. And we know that there's no more to go for because there was only one cycle in the domain. Let's sketch this graph. Label your points with coordinates of the endpoints. Let's start with the easy ones. What is the amplitude? It's 2. Period. Pi. Mean. 1. Meaning the mean is at 1. So the period, it should be, here are points. Cool. So we know that we found that 2 cos 2x plus 1 equals 0 when x is pi on 3 and 2 pi on 3, meaning it hits the x-intercepts at this point here and this point here. So let's begin with the starting point. Since the mean is 1 and the amplitude is 2, the range is going to be from here to here. And since it's a cos graph that's not reflected, it will start here and end here. And since it's going through one cycle, it'll have its final point there. So here's what this graph will look like. Make sure we label our endpoints, turning points, and axis intercepts. So here we have 0 and 3, pi and 3, pi and 2 and -1, 2 pi and 3 and 0, and pi and 3 and 0. I will make a separate video on how to get really comfortable with graphing. Now notice that there's such small details I really took into account. It wasn't a really long process. If anything, solving exact values is the hard part, and the graphing part should be easier. But it's a skill that not everybody can take on. So I'm here to help as well. Cool. Question 6. Given that f dash this, now this is an anti-differentiation question. So there's, with integrals, there's 2 separate types of questions. There's anti-differentiation and an integral. This is normally for areas on the graph, and this is for find f of x. This is a find f of x question, and if we compare it to the next one, yes, to see, we have an evaluate, and then later on we will have an area. Let's continue with this. What are our clues? F dash of x equals minus 2x, 3x minus 2 minus 4, and f of minus 2 equals 8. And we want to find f of x. Now, what we know is that when we take the derivative of f of x, we end up with f dash of x. And if we take the integral of f dash of x, we end up with f of x. So it's quite literally anti-differentiation. Now, currently, f dash of x is kind of in an annoying bracket form. So let's expand it. Okay.
So what we're going to do is f dash of x, the integral of f dash of x equals f of x. And this is what we're looking for. So let's do it. Minus 6x squared plus 4x minus 4 dx. This equals negative 2x cubed plus 2x squared minus 4x plus c. And that's equal to f of x. Now, this c part might be confusing, but let me quickly explain. If we have y equals x squared, what is the derivative? 2x. We have y equals x squared plus 5. What is the derivative? 2x. And guess where I'm going with this? It's 2x. Notice the derivative can be a derivative can be the equation can be the derivative for multiple different looking equations. So this is where the plus c comes from. Anything with an x squared plus a constant, its derivative will be 2x. So when we're anti-deriving, that's what we're taking into account. We call it an indefinite integral. However, they've given us this clue, which allows us to find this c. So what they told us is f of negative 2, let's start over here, is equal to 8. So that means if we plug negative 2 into this thing, it should pop us out an 8. So let's do that. So what I've done is I've subbed in negative 2. So it should become 416 plus 8 plus 8 plus c equals 8. So that means 32 plus c equals 8. C equals negative 24, meaning f of x is equal to negative 2x cubed plus 2x squared minus 4x minus 24. So that is that question done. Next, evaluate. Let's do this. Here, there won't be any constants because this is called a definite integral. Definite integral helps find area, evaluate certain numbers, but definite means there's no c. The question before was an example of an indefinite integral. So let's do this. X cubed minus 2x squared plus 6x. Note, no c. Now, what this notation means is we're going to plug in 2 and then subtract, plug in the top number, subtract it, and plug in the bottom number. So we're going to have 2 cubed minus 2, 2 squared plus 6 times 2, minus 0 cubed minus 2, 0 squared plus 6 times 0. And hint, this all goes to 0. We're left with this. And that is 8 minus 8 plus 12. And our answer is 12. Sometimes we can add a units, but that is fine on its own. Next question. For the function f of x equals 2x cubed minus 12x, find the average rate of change for the interval. Whenever we see average rate of change, we don't need to think about deriving. We think of this formula. F of b minus f of a over b minus a. Actually, y2 minus y1 or x2 minus x1, but with a little bit harder things, but it shouldn't be too bad. So if this is our interval, then it's going to be, and it can be f of a minus f of b over a minus b. just make sure it's all in the right area. We're going to do f of 1 minus f of minus 2 over 1 minus minus 2. Now, hopefully, it'll be nice to us, but let's calculate this on the side. F of 1 is equal to 2 minus 12. F of minus 2 is equal to, I'm going to have to go slowly with this one, 4, 8, 16, plus 24, which is 8. So we're going to end up with negative 10 minus 8 over 1 plus 2, which is negative 18 over 3, which is negative 6. So therefore, your average rate of change is, you can call it error, is negative 6. And a little bit of extra context is always nice for your teacher. Now, average rate of change, instantaneous rate of change at x minus 2. Basically, they want us to find f dash of x, and then what is f dash of negative 2. So let's do that. I like to write f of x right next to it. It just helps me focus and make sure I derive the right question. Minus 12, and f dash of negative 2 is 6 times negative 2 squared minus 12 equals 6 times 4 minus 12 equals 24 minus 12 equals 12. Now, I was fast, but I used so many steps. Now, you don't have to follow all these steps, but it's definitely a good starting point, especially if one of the main things of why you're making mistakes on tests or quizzes or anything is silly mistakes. If it just gives you insurance, really. Now, find the equation of the normal. Now, let's quickly get a formula going. We covered this last time. So imagine if this is A and B, we have y minus b equals 1 on f dash of A times x minus A. So we have A, we have B, we don't have f dash of A. So we need to find that before we can plug in our formula. So what is f of dash of x? We found that in the previous question. F dash of 2 is equal to 12. Perfect. So now we have y minus 8 equals 1 on, negative 1, sorry. Keep that in mind. It has to be negative, especially if it's a normal. If it's a tangent, it will not be negative. Times x minus 2. So if y plus 8 equals negative 112x plus 1 on 6, so y is equal to negative 112x minus 7 and 5/6. You can have it as 42, negative 47 on 6. Don't forget that. Hence, find the coordinates of the stationary points. Now, this question is poorly asked. Are we finding the stationary points of the normal we just found or the parabola? It is the parabola because, sorry, or f of x. That's me overanalyzing. But let's do that anyway. So we have f of x, what is it? 2x cubed minus 12x. And I'm sure the derivative will be useful, so let's write it down. Now, let's actually analyze the question. Coordinates of stationary points. Whenever you think of stationary points, think of when does f dash of x dy dx equal to 0. Let's do that. F dash of x equals 0, x equals 2. Oh, sorry. My mistake. It was 6x squared minus 12. So 6x squared minus 12 equals 0. We're going to go 6. X squared minus 2 equals 0, meaning x equals plus minus root 2. Because we turn this into
Anyways, so we need to find the coordinates. So we found the x, we need to find the y. So let's do root 2 and what? F of root 2 equals 2 times root 2 cubed minus 12 times root 2. We end up with 4 root 2 minus 12 root 2 equals negative 8 root 2. One SP. And the next one, negative root 2 and what? F of negative root 2 equals 2 times negative root 2 cubed minus 12 negative root 2 equals negative 4 root 2, sorry, negative 4 root 2 plus 12 root 2, which equals 8 root 2. Now, the calculation only really seems tricky because they are surds. But basically you find what is x when the derivative equals 0? Found that, and you just plug it back into the original equation. Final question. The rectangle WXYZ has two vertices, x and w, on the axis and the other two vertices, y and z, on the graph. Y equals 9 minus 3x squared, as shown on the diagram below. The coordinates of z are AB, where AB are positive real numbers. Find the area of the rectangle in terms of A. Now, this is quite a challenging question. So it will be difficult to understand at first, but it'll be okay. So find the area of the rectangle WXYZ in terms of A. It's going to be length and times width. So let's figure out what the width and length is. Let me quickly grab the charger for this. 1 second. I apologize. But here we go. So width is the height. So if the square changes, so it's a potentially moving square, the height will be B. However, they don't want it in terms of B, they want it in terms of A. So we can call the width F of A. In other words, 9 minus 3A squared, because F of X is equal to 9 minus 3X squared. Now the length is clearly going to be 2A. Maybe not clearly, but it makes sense because it'll be this way and this way. So that means the area is going to be length times width, which is 2A times 9 minus 3A squared equals 18A minus 6A cubed. Find the maximum value of A and the value of A for which this occurs. So 18A minus 6A cubed. Whenever you see maximum, you always want to think turning point. When you think of turning point, you always want to think of correct derivative equaling 0. So let's find the derivative. Cool. So when does 18A dash equal 0? I'm going to go 18, 1 minus A squared equals 0. 0, A squared equals 1, A equals plus minus 1. Now, normally you could just sub these two in and you have to do two formulas, but that gives it away. So chances are -1 will just give us a negative answer and +1 will give us the correct. This is almost playing the game. You know they have to give you a good value. You know it's going to have to work out correctly. So use that to your advantage. So the value of which A occurs is at A equals 1 occurs. tick. We have to do the max value. How would you do this? Sub back this into the original area. So 18 times 1 minus 6 times 1 cubed equals 12. So is there a unit? No. So it's just going to be 12 units squared. I love 12. Any other questions, let me know. But thank you for listening, and give me any feedback on whatever is going on. Awesome. Thank you.